In this question we have Maurice in an elevator. He is moving at a constant speed. We need to figure out what his normal force is. First thing we should do in this case is to draw a free body diagram. The forces on Maurice obviously are the force of gravity pointed down, and then since he is in the elevator, he's not floating, he's not moving down or anything, there is a force moving up. This is the normal force. One thing we also know from this question is that he's at constant speed. Things about constant speed that we know are acceleration is equal to 0 meters per second squared, and forces are balanced when we're at constant speed. What that leads us to see is that this free body diagram will now have equivalency lines saying that the force of gravity is equal to the normal force. Alright, once we have that calculated, we can start filling in some givens in this question. One given is that Maurice has a mass of 100 kilograms. We also know that the force of gravity gives us in Maurice an acceleration of negative 9.81 meters per second squared. And this negative comes from the fact that this acceleration is pointing downwards. As far as givens, those are all we have. One thing we can calculate though is that the net force in the y direction is equal to 0 newtons. You have to see that in this case the forces are balanced. Another way to say that the forces are balanced is that the net force is equal to 0 newtons. We're actually going to use two equations for this case. One is Maurice's weight is equal to F of g, which is also equal to m times g. This g should not be mistaken for grams. This g stands for the acceleration due to Earth's gravity. But from there, we can solve for Fg. All we have to do is plug in 100 kilograms for mass times minus 9.81 meters per second for acceleration, or the acceleration due to Earth's gravitational force. You get Fg is equal to minus 981 newtons. The question actually asks for normal force, and instead of saying that Fg is equal to Fn, I want to use a different way to solve that. I want to use the equation, the net force in the y direction is equal to the sum of all the forces, which is Fg plus Fn. We already know Fg. We already know Fnet. So by plugging that in, 0 newtons is equal to minus 981 newtons plus Fn. We can solve for Fn. Solve for Fn by isolating Fn and moving everything away from it. Add 981 newtons to both sides, and we get Fn is equal to 981 newtons, which in this case shows that it is also equal to F of g, and it also proves that the forces are balanced.